All right, let's take a look at number 1 on the section 2 worksheet. I use the concept of potential energy to describe how a covalent bond forms between two atoms. So we're talking about the formation process. And so remember, we have two different atoms, and they're both, constituted by nuclei and electrons. Now, one of these electrons is being donated from atom A, one of these electrons is being donated from atom B. But we still have these general electrostatic forces. We have the positively charged nuclei being attracted to the negatively charged electrons. Now, that's always going to be the case. But we also have these negatively charged electrons repelling each other, and we have these positively charged nuclei repelling each other. Now, when it comes to forming a covalent bond, what's going to happen is these positively charged nuclei are going to be attracted to each of these negatively charged electrons, and they are going to be moving closer to those objects. And so they're going to move closer. Now, as they satisfy or actualize this electrostatic attraction, okay, the positive-negative attraction, potential energy is going down, right? Because there's a lot of energy available for this movement to happen. But as the movement does in fact happen, that potential energy goes away. There's not as much potential for movement. Now, you guys remember that nature favors these low potential energy arrangements. So these are going to continue to move closer and closer together. These two nuclei, the atoms, are going to move closer and closer together. Now, at some point, the force, the attractive force that the positively charged nuclei and the negatively charged electrons feel for each other is going to be equal to the negative repulsion between the electrons and the positive repulsion between the nuclei. Now, once all of those forces equal each other, okay, so we have an attraction force and we have a repulsive force. When those perfectly equal each other, potential energy is no longer decreasing. It is at its minimum. And if nature favors low energy arrangements, the lowest energy arrangement is going to be the most favored. Okay, so that's the point at which the bond length is going to be set. So how are we going to write that in terms of language? Let's take some time. As the atoms involved in the formation of a covalent bond approach each other, the electron-proton attraction is stronger than the electron and proton repulsions. During this point, the atoms are drawn to each other and their potential energy decreases. Nature favors low energy arrangements. Eventually, a distance, again, it's the nuclei from one another. A distance is reached at which the repulsions equals the attractions at this point. Potential energy is at its minimum, and a stable molecule forms. Know that I was a bit wordy, but this was one of your objectives, understanding the relationship between potential energy and bond length in covalent bonds.